This lecture continues talking about polynomial functions and their graphs. By now moving into the following topics. So in the previous lecture, we talked about what exactly is a polynomial function and the end behavior of polynomial functions, okay, by using what was called the leading coefficient test. Here we want to now talk about how you use factoring to find the zeros of a polynomial function. So I'll explain in a second what zeros are. And then what we'll do is we'll talk about how you identify zeros and what's called their multiplicities. Okay, so let me skip to this part here. All right, so here I'm going to start with this example. So finding the zero of a polynomial function. So let's find the zeros of this function. So what exactly is a zero? So a zero of a polynomial function. So we find these things called the zeros of the function f by setting f of x equal to 0 and solving the resulting equation. So you solve for x in f of x is equal to 0. So really, in terms of the graph, what you're finding the x-intercepts. Okay, so whenever you say, oh, find the zeros of the function, it's really like, what are the x-intercepts? Okay, so for this right here, okay, so to set this equal to 0 and solve, so we're going to take x cubed plus 2x squared minus 4x minus 8, and we're going to solve it by factoring. So you have a 4-term polynomial, so you're going to solve by factor by grouping. So I'm going to group the first 2 terms, put the negative in, so this becomes 4x plus 8. All right, what can I factor out of this? Right, well, just looking at it, I can factor out an x squared. I'm going to factor out a 4. Notice they each have an x plus 2. Well, does x squared minus 4 factor? Absolutely. That factors into x plus 2 times x minus 2. So just moving this up here, really what we have is x plus 2 squared times x minus 2 is equal to 0. So look, you have two solutions. You can either have x plus 2 squared is equal to 0, or you can have x minus 2 is equal to 0. You see very simply here, take the square root here. One solution is x is equal to negative 2, and x is equal to 2. So this function has 2 zeros. At x is equal to negative 2 and x is equal to 2. Now look, if you just look at the graph of this, right? So we saw that the zeros were negative 2 and 2. So the graph of f shows that each zero is that x-intercept that I said. And so notice here, and this will come up in a second actually. Notice here that at negative 2, it just touched the graph and turned. And then at x is equal to 2 here, it actually went through. So the graph touches, okay, kind of like a turning point here, whoop, and then here it went through. The turning point, knowing if it turns or goes through, is going to be determined by its multiplicity, and I'll cover that in a second here. All right, let's just do another one real quick here. So let's find the zeros of this. F of x is equal to x cubed minus 2x squared plus x. All right, so to find the zeros, you set it equal to 0. And you solve. So I'm going to solve this by factoring. All right, factor out an x. So does this trinomial factor? All right, like what two numbers multiply to positive 1, sum to negative 2? Well, that's just x minus 1 times x minus 1. Well, look here. You have x times x minus 1 squared is equal to 0. So look, just solving here, either the first factor, x is equal to 0, or this, x minus 1 squared is equal to 0. Well, here 0 is just x is equal to 0, and obviously here when you square root, you just get x minus 1 is equal to 0, x is equal to 1. So this function has two zeros at x is equal to 0 and x is equal to 1. Now, it just happened by example here that this function had two zeros and this function had two zeros, but it can have more, and that's okay. All right, this is just an example where there were only two x-intercepts. This one also had two x-intercepts, but graphs can have 2, 3, 4, 5, whatever. It just depends on how the function is defined. All right, now notice how this factor, this x minus 1, had a squared here. And even going back, looking here, this x plus 2 had a squared here. That causes something very interesting to happen, all right? And this is when we start talking about multiplicity and x-intercepts. So in factoring, the equation for a polynomial function f, if the same factor, x minus r, occurs k times. So what this means is if it looks something like this. Let's say x plus 2 to the third power times x minus 5 squared, okay? Note this exponent here is the k, okay? So notice this factor, x plus 2, occurs 3 times, and then this x minus 5 occurs 2 times. All right. So we call r, okay? In this case, r would be -2, and here r would be 5, okay? Multiplicity k. So we're saying this -2 has multiplicity 3, and this value of 5 has multiplicity 2, okay? So the multiplicity is the exponent, okay? All right, so if r is a 0 of even multiplicity, okay? So like, for example, this one right here, okay? Okay, so this value here, it's x minus r, so r here is 5. So this has even multiplicity. All right, the graph touches the x-axis and turns around at r. So look, even going back here, notice how we said x plus 2 squared, so the x was equal to -2, okay? Notice that the graph touched it, and turned right around. If r is a 0 of odd multiplicity, okay, that includes 1, 3, 5, okay, then the graph crosses the x-axis at r. So here, x plus 2 cubed, this occurs 3 times. So here, x is equal to -2 has odd multiplicity. So what this means is the graph, when you go to sketch the graph of this polynomial function, at that x-intercept, it's going to go right through it, okay? It's going to go right through it. It's not going to turn around like it did here. It's going to go whoop right through. All right, so regardless of whether the multiplicity of a 0 is even or odd, graphs tend to flatten out near zeros with multiplicity greater than 1. Okay, so, you know, if the multiplicity is 2, what this means here is, like, looking back, it's going to flatten out as it gets closer, and then before it blows up, all right, in either direction. All right, so let's do this example here, okay? Let's find the zeros of this function. So f of x is equal to -4 times x plus 1/2 squared times x minus 5 cubed, and give the multiplicities of each 0. Okay, state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. Okay. All right, so the first thing we need to do is find the zeros of this function. All right, so let me rewrite it over here. So f of x is equal to -4, and then in parentheses, x plus 1/2 squared, and then in another parentheses, x minus 5 cubed. All right, well look, the -4 here doesn't matter. Okay, so you're going to look at this expression here. So x plus 1/2 squared is equal to 0. Or this one here, x minus 5 cubed is equal to 0. Well, look, if this is going to be equal to 0, then what's underneath the exponent here in the parentheses has to be equal to 0. So x plus 1/2 is equal to 0. So x 1, 0 is x is equal to 1/2. But look, you see that it occurred twice, so its multiplicity was an even number. It equals 2. So going back, what happens? What happens at an even multiplicity? It's going to touch the graph and turn around. So it touches at x is equal to 1/2 and turns. Now look over here, all right? We have a 3 out here, but so x minus 5 has to be 0 or x is equal to 5. But here the multiplicity is odd, it's 3. Okay? So what happens when the multiplicity is odd? The graph crosses the x-axis here, okay? So the graph crosses the x-axis at this value x is equal to 5. What's really cool is, like, let me show you what I mean by it touches and turns and crosses through. Okay, so here's the graph if we were to actually like plug this in our graphing calculator and look. So I said it's going to turn here at 1/2. So it's going to come down and it's going to turn. It's going to turn real quick. Okay, it's not going to cross through it. It's going to hit that and turn. And then we saw here that at x is equal to 5, it's going to cross through it. So remember, it's going to flatten out as you get closer. It's going to go to 5, and then it's going to not turn back around, but go right through it. All right, so there was a lot going on there, okay? A lot going on, but really important to understand that this multiplicity, this turning, or if it goes through it. All right, let's do one more, all right, just so you could see. So let's find the zeros of the following function and give the multiplicities of each zero. State whether the graph of the x-axis, state whether the graph crosses the x-axis or touches the x-axis and turns at each zero. All right, so what you're going to do here is you're going to take this, you're going to set it equal to 0. All right, that's how you find the zeros. So we're going to solve this by factoring. So we're going to factor out an x. So look at this resulting trinomial, right? So what two numbers multiply to 4 sum to 2? Well, that's x plus 2 times x plus 2. Well, look here. X plus 2 times x plus 2. That's x plus 2 squared is equal to 0. All right, so look. When you have x by itself, what's really there? It's an invisible 1. So you have 1, 0 when x is equal to 0. Okay? All right. Notice here the multiplicity is equal to 1, so that's odd. So when you have an odd multiplicity, right, because the exponent there is 1, right, it crosses the x-axis at x is equal to 0. Now looking at our other 0, x plus 2 squared could be equal to 0. Okay. Well, look, so what only matters is underneath here. So x plus 2 is equal to 0. So x 1, 0 is x is equal to negative 2. But its multiplicity is this exponent. The exponent was a squared term. So that's even. So what does that mean? It touches the x-axis at x is equal to negative 2, and it turns. Okay. So what we're going to be doing, all right, you're going to see all right, that we're going to use what's going on here. So hopefully you can see where this is building. So we know the end behavior. Now we find the x-intercepts, okay, the zeros. And now we know if it's going to cross the x-intercept or if it's going to touch it and turn. And all of this is going to start helping us build towards graphing it, which is what we'll do in the next lecture.